Banks in Manila. What do you think that can damage your banks and the money? Earthquakes. One of the most destructive and powerful natural disasters. They are caused by many different reasons, such as dislocations of the segments of the Earth's crust, volcanic eruptions, man-made explosions, and such. The science behind this is that when earthquakes occur, earthquake loads are occurred. Earthquake loads are one of the forces those are caused when the ground beneath the structure shakes back and forth. This is how many buildings, structures, and such destroyed during the earthquakes. However, the biggest reason why the earthquakes happen is because of the dislocations of the Earth's crust. The biggest reason why earthquakes happen a lot in the Philippines is because Philippines is located inside the Ring of Fire, the region where the earthquakes happen the most in the Earth. And now that Philippines is located inside the region where the earthquakes happen the most, earthquakes have been damaging Philippines through history, including Manila. Many people were killed, roads and buildings were destroyed. It left so many mental scars in people's mind. And there are some ways to measure the magnitude of the earthquake, such as seismic graphs and seismic scopes. Now, the reason why this problem can be really huge one that can affect the entire Philippines, not just Manila, can be found out by the examples. Take a look at this. This is the picture of a bell tower of the Manila Cathedral after the series of destructive earthquakes of July 1880. And this is the damage caused by the tsunamis at Barangay Tipuan after the earthquake with a magnitude of 7.9 Morgulf earthquake stroke. Some people might think that this is not that serious, but it is. We desperately need a solution for these problems. Those are causing many damages to the Philippines, including Manila.
Hello, Bank of Manila. We have heard you would like to build an earthquake-proof skyscraper. Luckily, we came up with a very safe solution for you. Now, this solution will let your building stand out. It will let your bank improve, as your bank will not break every time. And it will let people invest in your bank, as they will put their money in it because they know your bank is more reliable than the other ones, as yours will not break down. Now, this is our final design. These are 3 earthquake resisting solutions which have been combined to make one big solution. First solution is using the dead load, so you would need to make sure to make your building strong. This solution involves levitating your building using air pressure. The science behind this solution is simple. There are compressors lined up at the bottom of the building connected to a sensor. When the sensor goes off, the pressure is released rapidly enough so that the skyscraper stays in the air while the earthquake is occurring. The materials used is an air compressor, an earthquake sensor, and some jets on the bottom. These are the jets in the bottom. Preferably it would be in aluminum, as aluminum is lightweight, and that basically means the building will not be as heavy, and it's stainless steel, so it will not rust and it will not swell. If it rusts and swells, it has a chance of shifting your building so that it might crash into the floor, flying sideways. Then we have another solution in case this solution has any flaws. The next solution is having base insulation. These insulators are basically connected by 2 attachment plates, as you can see here and here, and they have rubber layers connected like this with some spacing, and the spacing is stiffening plates. In the middle between both sides there's a lead plug, basically allowing the piece to shift sideways, allowing the building to stay straight, as if there was an earthquake with a fixed base instead of an isolated base. Then the whole building would collapse, and this one, the building is still straight, as you can see. Now, don't worry if this solution for some reason does not work. We still have a third solution, but the third solution has another science. This science behind this solution is that it allows the building to bend and being pushed back up, as if the building will not resist. Then it might have a chance to survive an earthquake. This solution involves the force of compressing. The materials used in this solution are various. Unfortunately, we may not manage the materials in this solution, or else it may not work. Now, this is our last solution. It's called a spherical sliding system, and it basically allows the moving building to move right and left. As you can see, if, for example, the building would move in on towards the right, the earth would move, the building would move in an uphill and then would move directly back. Because this piece here is loose compared to here, but to make sure that your building would not just tilt over to one side, we added these green stuff here, which would ensure your building not tilting over. If for some reason this fails, your building will be standing on a giant sphere. The science behind this is as the one above, as I stated, it also uses the compression force. But when the building shifts left and right, the earthquake cannot make the building fall. To prevent the building from tipping over, we have added concrete blocks on the sides and the building on the platform, so that the building won't tip over. The materials to create this is going to be made out of reinforced concrete. The pros and cons of reinforced concrete are you can compress it a lot, and the sphere is going to be compressed by the building. It's fire and waterproof, allowing fire to burn down there. If, for example, there's some debris of some electrical circuits falling from another building right down here, then it would still be able to work. It might get jammed, and this is where these would kick in, the insulation. Now, it can mold into any shape, which allows us to make it in a sphere. The only cons it has, it is quite expensive and it can crack as it's cooling from the molding process. Our earthquake-proof building helps not only the bank's economy, but also the country's. It mainly helps the economy and the health of other people. The earthquake-proof skyscraper can now help the economy of the countries, because when the banks will loan money to the government, then you will be able to collect the money from the government, and the government would be able to collect money and build buildings, and then they would earn money and they would pay back the banks. This would also work with people. As you are able to pay loans to poor people, you can receive money from them, and they will maybe also build some buildings. Then with this earthquake-proof skyscraper, you can make a motto saying, because we care, or something that would be true, because you're having a lot of money investing in your earthquake, and then you can say you're preventing it from falling on people's heads and killing millions of people around it and in it. Now this can be good for the economy, but as I said earlier, this is also good for the health and social aspect. When an earthquake hits, many buildings will fall and few will resist. The falling buildings can kill, injure the people in them, and few will resist or around them. If the building does not doom, it does not break, then the building might have a good possibility to reduce the deaths within its building itself and around it, because it will not collapse around it. But then your building will be probably one of the only ones after a strong earthquake to survive, and people would be like, whoa, we still have a big building, look at us, we're Manila. So they would be happy. Thank you for watching.